Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Horseshoe Toss by Not Very Neat. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have region sum lines, where box borders divide blue lines into segments with the same sum. The sum may be different for different lines. So, for example, say this was 2 and 4. Then this digit would have to be 6, because the sum of the segments on this part, the segment here, must equal the sum of the segment here, which must equal the sum of the segment here. So this could be something like 2, 4, 1, 5, and 6. And this would work because 2 and 4 add up to 6, 1 and 5 add up to 6, and obviously 6 adds up to 6. And that's an example of how region sum lines work. We also have Dutch whispers, or as I like to call them, whisper 4 lines. And I only do that because a setter came up with the phrase, and I thought it was brilliant because it's very extendable. Where we have adjacent digits on an orange line have a difference of 4 or more. So, for example, if this were, say, a 3, this digit would have to be 7, 8, or 9, because those are the only digits which are 4 or more away from 3. So that's an example of how a Dutch whisper, or as I'm going to call them, whisper 4 lines, work. And finally, we have Kropke dots, where digits separated by a white dot are consecutive, and digits separated by a black dot are in a 1-to-2 ratio. Not all dots are necessarily given. So, for example, say this was a 6, this would have to be 5 or 7 to make sure that these digits are consecutive. And if this were, say, 2, this would have to be 1 or 4 to maintain the 1-to-2 ratio that's between them. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, we've got a lot of black Kropke dots, but do we have enough? One thing we know is if you have two digits that are next to a black Kropke dot, if you have two digits with a black Kropke dot in between them, and they're also neighbors on a whisper 4 line, the only possible combination you can have is 4 and 8. 1 and 2 doesn't have a difference of 4. 2 and 4 doesn't have a difference of 4. And 3 and 6 doesn't have a difference of 4. And 5, if you double it, you get 10, which is obviously not a digit. So this has to be a 4-8 pair in every whisper 4 line, which has a black Kropke dot in between them. So, what does that mean for this black Kropke dot? It has to either be 1, 2 as a pair, which adds up to 3, or it's 3, 6 as a pair, which adds up to 9. Okay. Same with this, I guess. It's 1, 2, 3, or 6. This is 1, 2, 3, or 6, but this doesn't have to be the same thing there. Okay. Okay, so one of these digits is going to be a 4. The other one is an 8 because of the 4-8 pair in the column. So if this is 4, this would have to be a 9 here. If this is an 8, it would have to be 1, 2, or 3 because this can't be 4 because of the 4, 8 pair in the box. With this one, it's slightly different. It could be 9 here if this is 4, and this would be 1 through 4. Well, if this is 4, this would guarantee that there's a 9 here, but we already know one of these is 4. Oh, wait, it could be next to 8, too. Ooh. That's not helpful. Well, let's just continue with what these could be. If this is 8, so 4 can be next to 8 or 9, but this can't be 8 or 9 because of the 4, 8 pair in the box. But this could be 8. And this could also be 4 here. If this is 4, this has to be 8 or 9. And this would be... If this is 8, it's 1 through 4. We know neither of these could be 4 or 8 because of the 4, 8 pair in the column. Neither of these could be 4 or 8 because of the 4, 8 pair in the column. Huh. Does that help us any? Not particularly. This has to be 1, 2, 3, and 6 here. So this obviously could be 1, 2, 3, 6 here. It cannot be 8. It could be 4 here, though, also, to be in a 1 to 2 ratio with these digits. Do we have anything else? Oh, this... Oh. Wait, no, that's not... I was thinking this is region sum, but that's not the case. Okay, so this is either 1, 2, which adds up to 3, or it's 3, 6, which adds up to 9 here. So this becomes a 3, 9 pair, which eliminates 3 and 9 in the rest of the column and box. So that can't be 3, 9. This can't be 3 or 9. Well, that's interesting. So since this can't be 3, this can't be 6 here. So where is 3? What happens if this is 1, 2? If this is 1, 2, that forces this to be 3. Otherwise, this is 3, 6 as a pair, which means obviously 3 is in one of these two cells. So 3 is guaranteed to be in one of these 3 cells here. This adds up to 3. So, if this is 3, this has to be 1, 2 as a pair. Huh. Okay. So if this is 1, 2 as a pair, this would have to be 2, and this would be 4 if that were the case. Right, so if this is 1, if this is 3, this is 2 and 1, and then this would be 4. So that's potentially possible. Otherwise, if this is 9, this is 3, 6. This would have to be 3, so it's 1, 2 there. So we know these are different, so these must be different sums. So this digit cannot be 4, 8. It cannot be 1, 2, or 3, 6. Because one of these is going to be 3, 6 to add up to 9. The other one has to be 1, 2, adding up to 3. So no 1, 2, 4, 8, 3, 6, or 9. So this has to be 5 or 7 there. If this is 9, that means this is 1, 2 here. This could be 1, 8, 2, 7, 3, 6, or 4, 5. 1, 8, 2, 7, hold up. But if this were 1, so if this adds up to 9, this is 3, and that would be 1, 2. So this couldn't be 2. So 1 could not be here either way. So that means 1 would have to be here, and this would be 8. 2 and 7 works. 3 and 6 does not work here, because if this were 3, that could only be in a 1 to 2 ratio with 6, which would be here. If this is 6, that would force that to be 3, which would have to be here to add up to 9. So that's not possible. Or this has to be 4 and 5 adding up to 9. With 4 being there and this being 2, it cannot be 2, it would be 8. Interesting. So one of these is guaranteed to be 4. We're not sure which. So again, if this is 3, this is 1, 2, 1, 2, and that's 4. If this is 9, this could be 1 and 8, if this is the 8, because 1 can't be here because that would be 1 and 2. 2 and 7 works. 3 and 6 does not work because that would force this to be a 3, 6 pair. And they wouldn't then add up to 9. And then 4, 5 works. So those are the possibilities there. Okay. This is either 1, 2, which would have to be consecutive with 3. Ah, that doesn't work. So if this is 1, 2 here, and this is 3, that would force this to be a 1, 2 pair here. The only one digits which can be consecutive with a different digit than 1 or 2 would be 2 being consecutive with 3, but this can't be 3 because of the 3, 9 pair in the column. So this cannot be 3, this has to be 9, which makes this a 3, 6 pair to be in a 1 to 2 ratio. That makes this 3, which makes this 1, 2 as a pair here. Means this can't be 1 or 2. That's 3, which is in a 1 to 2 ratio with 6. That leaves this as 1 and 2, adding up to 3. 2 is in a 1 to 2 ratio with 4 here. And this is a 1 to 2 ratio. It cannot be 1, 2, 3, or 6, so it's 4 and 8, which makes this 8 and that 4. This must add up to 12 here to add up to the same sum as this. Cannot be 3, 9. Could be 4, 8, or 5, 7. We're not sure which. 4 eliminates 4 from being here. Where is 4 in this upper left-hand box? Can't be here because of 4 in the column. Can't be here because of 4 in the column. Can't be here because of the 4, 8 pair in the row. So it must be one of these two. So this is either 4 with 2 or 4 with 8. We're not sure which. This adds up to 9. So no 1 or 8 here, because this can't be 1 or 8 as a pair, adding up to 9. Could be 2 and 7 if this is 2 and that's 7. Could be 3 and 6. Cannot be 4 and 5 because of the 4 not being able to be in either cell here. So if this is 2 and 7, this would have to be 8 here to be consecutive with it because it can't be 6. If this is 3 and 6 here, this could be 5 or 7. Okay, cannot be 8 here because of the 4, 8 pair in the box. So this can't be, this has to be 3 and 6 here. So if this is 6, this is 5 or 7. If this is 3, it's 2 or 4. Cannot be 4 because of the 4, 8 pair in the box. So these are the possibilities here. If this is 2 and 4, this cannot be 2 and 4 here because of the 4 in the box, so it would have to be 1 and 5. If this is 4 and 8, it cannot be 3, 9, or 4, 8, so it would have to be 5 and 7, which means we have a guaranteed 5 in one of these cells. This can't have 3, 4, or 6. It could be 1, 2. It could be 7, 8, or it could be 8, 9. This can't be 8 because of the 4, 8 pair in the row. So therefore, this is 1, 2 as a pair, or it's 7, 8 there, or 9, 8 there. Okay. Hmm. 2 eliminates 2 here. So this must be 1 and 2 there. Where is the 4 in the central box? Can't be here because of the 4, 8 pair in the row. Can't be here because of the 4 in the row. Can't be here because of the 4, 8 pair in the column. And this is already filled out, so this must be 4. So since this is 4, this has to be 4 or more away from it. So this is 8, that's 4. 8 eliminates 8 from being here, and this 4 eliminates 4 from being here. So that leaves this as a 4 here. 4 can only be next to 8 or 9 on a whisper 4 line, so this can't be 8 because of 8 in the row, so this is 9, which can be next to 1 through 5 on a whisper 4 line. Can't be 4 because of the 4, 8 pair in the column. If this were 8, this would have to be low, but it can't be 1 or 2 or 4, so it would have to be 3 in that instance. If this were 1 or 2, it could be next to 5 through 8 here, but it cannot be 8 because of the 4, 8 pair in the column. So it's 5, 6, or 7. Okay. If this were 3, it would have to be 7, 8, or 9 here. Could not be 8 because of the 4, 8 pair in the box. If this is 5, 6, or 7, 5 would have to be with 9 there. 6 would not work because it would have to be next to 1 or 2, and this can't be 1 or 2 on the whisper 4 line. 7 would have to be with 3. So we're guaranteed one of these digits is a 3. We don't know which. 4 being here would force this to be 9, because it cannot be 8 here, and 4 can only be next to 8 or 9 on a whisper 4 line. 8 could be with 1, 2 here. Okay. So if this were 1, 2... Okay, so this can't be... This has to be consecutive. Where is 9 in this right central box? Can't be here because of 9 in the row. Can't be here because 9 is only consecutive with 8. And 8 is already taken because of the 4, 8 pair in the box. So this can't be 9, this can't be 9 because of the consecutiveness. This can't be 9 because of 9 in the column. So this has to be 9 here, which is 4 or more away from 4, which makes that 8. This cannot be 4 here. This can't be 8. But where is the 4 in column 4? Can't be here because of 4 in the boxes, and this can't be 4 because of 4 in the row. This is filled out, so this must be 4 here, which makes this 4 and 8 adding up to 12, to add up to the same sum as this sum. Okay, so this is 9, which can be next to 1, 2, or 5 on a whisper 4 line. This also eliminates 9 from being here. So this can no longer be 5 here, because if this were a 5, it can only be next to 1 or 9 on a whisper 4 line. So this is a 3, 7 pair here. Interesting. The remaining digits then in row 7 are 5, 6, and 9. Okay. This can't be 6, so it's 5 or 9. This becomes a 5, 7, 9 triplet. Interesting. So since this is a 5, 7, 9 triplet, that eliminates 5, 7, 9 in the rest of the column. So this can't be 9 here. This is 1, 2, or 3. 4 can never be next to it on a whisper 4 line because it's not going to be 4 or more away from it. So this has to be 8 here, which makes this 4. 8 eliminates 8 here, so it's 4 and 8. 4 can only be next to 8 out of 1, 2, or 8 on a whisper 4 line. That leaves this as a 3. This as a 7. That eliminates 3 from being here. So this is 8 here. Where is the 8 in row 4? Can't be here because of the 8s in the boxes. Can't be here because even if this adds up to 12, we can't have 4 and 8 here because of the 4 in the box. So 8 has to be here, which is next to 7 or 9 on for the white crop key dots. So where is 2 in this box? This is 8 here, which makes this 2. So this must be adding up to 6. So this is 1 and 5 adding up to 6. This can't be 2 because of 2 in the column, and the rest is filled out. So this must be 2 here, which eliminates 2 being here. We have only 7 and 9 remaining in this left central box, and 9 can't be here because of 9 in the row. So this is 7, which makes this 9. Again, remaining digits in row 7 are 5, 6, and 9. So this is 5, 6, or 9. This can't be 9 here because of 9 in the column. This can't be 6 here because of the 3, 6 pair in the column. So we have a 5, 9 pair in row 7, which means this can't be 5 or 9. It's 6. Remaining digits of column 3 are 7 and 9. That's fine. Remaining digits of column 1 are 1, 5, and 3. And this can't be 1 here because of 1 in the box, so this must be 1 here. Therefore, this is 3 and 5. This can't be 3 in this row because of 3 in the row. So this is 5 and 3, which eliminates 5 here. Let's see. The remaining digits of row 6. We have 1, 5, and 6. This can't be 1 because of 1 in the column, so this is 5 or 6. We have 1, 5, 6 here. 1 can only be consecutive with 2. 5 can be consecutive with 4, which can't be there because of 4 in the box, or 6. 6 can be consecutive with 5 or 7. Okay. Remaining digits of column 5. We have 5, 6, 7, 9. And this can't be 9, so this can't be 5. This is 6, 7. So that forces this to be 9 here. Well, we have a 5, 6, 7 triplet in the central box, which eliminates 5, 6, 7 in the rest of the box. So this becomes a 1, 2 pair here. Oops. Which eliminates 1 and 2 in the rest of the row. This can't be 2. This can't be 6 because of the 3, 6 pair in the row. So this is 5 or 7, which can only be consecutive with 6. So that's 6, which makes this 5, which makes that 7 and 6. 5 eliminates 5 here, so it's 1. This can no longer be 1 here. This 7 eliminates 7 here, so this is 5. Remaining digits in row 4 are 2, 3, and 7. This can't be 3. This can't be 7 because of the respective 3 and 7s in the column. This 5 eliminates 5 here, so it's 9, which makes this not 9, so it's 5. That leaves the remaining digit in this lower left-hand box as 7. This can't be 5 or 7. It's 9, which makes this 7. Remaining digits of row 8. We have 5 and 6. Okay. Remaining digits of row 9. We have 1, 2, and 9. And this cannot be 1 or 9 because of 1 or 9 in the column. So this is 2. This can't be 9 because of 9 in the column. So it's 1, which makes this 9. 2 eliminates 2 here, so it's 7 and 2 here, so it's 5. That 5 eliminates 5 here, so it's 6 and 5. This can't be 7 again. This 9 eliminates 9 here, so that's 7 and 9. Remaining digits in column 2 are 5 and 8. This can't be 5 because of 5 in the row, so this is 8, which makes this 5. This 2 eliminates 2 from being here. Remaining digits of row 1. We have 2, 3, and 6. This can't be 3 or 6 because of 3 or 6 in the column. So this is 2. Either of these could be 3 or 6. This can no longer be 2 here. 5 and 7 is only consecutive with 6 out of 3 or 6. So that's 6. This is 3. This is 6. That's 3. 2 here eliminates 2 here, so that's 1 and 2. That leaves this as a 5-7 pair in column 4. This can't be 5 because of 5 in the row. So this is 7, that's 5. We have 3 and 6 remaining in row 1. That's not helpful. We have 1, 3, and 6 remaining in... Oh, no, that is helpful. We have a 6 here. So 6 eliminates 6 here, so that's 3 and 6. That's 3 in the corner. We celebrate because we know we're close to solving it. 3 eliminates 3 here, so it's 2 and 3. Remaining digits of column 8 are 2 and 6. 2 can't be here because of 2 in the row, so that's 6 and 2. Remaining digits of column 9 are 1 and 7. This can't be 7 because of 7 in the row, so this is 1, which makes that 7, which eliminates 1 here, so it's 3 and 1. And that's the solution. Interesting. I don't know if I would classify this as very easy. Execution-wise, it's probably about easy level. The logic behind, or maybe a little harder than easy level, actually, thinking about it. Yeah. It's just, yeah. Basically, I guess you have to find this part, right? You have to find that what these are equal to. Yeah, maybe it is easy level of execution. You just basically try that. If that's 3, then this is 1, 2. But then the problem is 2 has to be consecutive with 3. So maybe it is easy or very easy. I don't know. It didn't feel as straightforward as most very easy puzzles. So I think I would classify it on the whole as easy. But it's not too bad. Nice little puzzle. Nice interactions between the black crop key, white crop key, region sum lines, and whisper 4 lines. So overall, just a nice puzzle. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.